Hello everyone, I'm Frank and welcome to Frank's Puzzles. This month I'm going to be trying to do two puzzles every day. One in the very easy to easy difficulty and one average and above difficulty. And this one today is going to be a little tough because it seems like it's a hard difficulty level puzzle. So, anyways, let's get into it. Today's puzzle is called Peace Dove by Furba, I believe. And here are the rules. Normal Sudoku rules apply. That means place the digits 1 through 9 in every row, every column, and every box. Digits must not repeat within the same... Okay, well, yeah, that's normal Sudoku rules apply. Digits cannot repeat within the same row, column, and box. Region sum lines. Box borders divide the blue line into sections that sum to the same total. Which means that, again, so these three cells would have to equal the same sum as these three cells, which has to equal the same sum as these two cells, which is the same sum as these three cells, which is the same sum as etc., right? All of these have to be the same. Interesting. That does tell us a decent amount of information. And then we have Kropke dots, or Kropke pairs. Digits separated by a white dot are consecutive. So if this was a 7, it would have to be next to a 6 or an 8. And there's two sets of Kropke pairs. And that not all dots are necessarily given, which means that we only have positive information, which means we know that these are consecutive, but there could be consecutive digits next to each other everywhere and many other places. So those are the rules. If you want to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so yeah, this one seems to be driven by the box border, the region sum line, which where these three equal these three equal these two equals these three, right? And the key is that there's one by itself. So this one means that it equals a set which has 3 in it. This also has 3 in it, and this also has 3 in it. And they're all in the same 2 rows. Well, this also has 3. This also has 3. This also has 3. This also has 3. We also have the 3 here. There's a 2, a 2. Ah, that's key. So this is 2, this is 2, this is 2, and this is 2. And they all have to equal that digit. So first of all, then, where can this digit be? Right? This is 9, and that has to be 9. So this is all 1 through 8. This is 1 through 6. This is 1 through 6. All of these are 1 through 6. So where is the 9? So this has to be a 9. This is 1 through 6. So this has to be 1 through 7. These are all 1 through 6s. Oops, not that one. So these are all 1 through 6. This is also 1 through 6. So one thing we know is this set of 3 digits is not the same as these 3, right? Because 2 of the 3 would have to be here. Okay. These 3, however, could be the same as these 3, or could be the same as these 3. So there's at least 2 distinct sets. So we know that these 3 are going to be different from those 3, but these could be the same. These three have to be different from these three, but these could be the same. Those three cannot be the same as those three, but this one could be the same. And then these three cannot be the same as these three. Okay. Hmm. Okay, where is 9? So the 9 could be here or here. One of these is 9. One of these is 9. One of these 4 is 9. One of these 4 is 9. And one of these 5 becomes 9. One of these 5 becomes 9, yeah. So, not the most helpful. Oh, wait. Can these be the same? No. They have to be different. All of these have to be different. All these 3 sets have to be different, right? Because, okay, the thing is, in any 3 set that adds up to 9, you always have 2 out of 1, 2, and 3, right? So it could be 1, 2, 6, 1, 3, 5, or 2, 3, 4. So you'll have 2 out of 1 and 2 here. Sorry, you have 2 out of 1, 2, 3 here. You'll have 2 out of 1, 2, 3 here. You'll have 2 out of 1, 2, 3 here. So that's 6 out of 1, 2, 3 in 2 rows. And there's only 6 1, 2s, and 3s. So this cannot be 1, 2, or 3. This has... So everything within these 2 rows... Okay, so let's remove the 9s. The 9s is not helpful right now. So everything in these 2 rows have to be... cannot have a 1, 2, or 3 except being in those three set combos that add up to 9. Same with these columns, right? These columns cannot have a 1, 2, or 3. These columns cannot have a 1, 2, or 3. So we know that these cannot have a 1, 2, or 3. These cannot have a 1, 2, or 3. These cannot have a 1, 2, or 3. And these cannot have a 1, 2, or 3. And these. And these. And these. Oh. Okay, so where is one of the 1, 2, or 3s has to be here. This has to be 1, 2, or 3, right? Because it can't be here because there's 6 already accounted for in those 2 rows. It cannot be here because it's already accounted for in those 2 rows. So this has to be 1, 2, or 3, right? Similarly, I think this also has to be 1, 2, or 3, right? So you have these rows already have all the 1, 2, 3s accounted for. These rows have all the 1, 2, 3s accounted for. So this has to be 1, 2, or 3. I think that means for all the corner boxes, it's the same thing. So this is 1, 2, or 3. This is 1, 2, or 3, right? And we have one final 1, 2, 3 here, and one final 1, 2, 3 here. We don't know which. So this is 1, 2, or 3. It cannot be next to 1 or 2 or 3 because we have 2 of them here, and that's the third. So this has to be 4. So this has to be 4 and 3. So this cannot be 3 or 4. No, 3 or 4. This is 1, 2, and 6. So this is 1, 2, and 6. This can't be 3. This has to be 3, so this can't be 6. This can't be 6. This can't be 6. And this part can't be 4. No 4. This can't be 6. This can't be 3, right? So one of 1 or 2's here. That's 1 or 2. This is 1 of 1, 2, or 3. So the 6 could be here. We don't know which. Right? So this is either 1, 3, 5 or 2, 3, 4. This is 1, 3, 5 or 2, 3, 4. So the rest of this is 5, 7, 8, 9. This is 5, 7, 8, 9. Okay, can't be 9 there. So this one of these three is 5, 7, 8, 9. Okay, so we know. Okay, this is 1, 2, 3, 5, 1, 2, 3, 5, 1, 2, 3, 5, 1, 2, 3, 5. Okay, so let's remove the coloring because I can't see part of it. So this can't be. Let's just remove all the coloring. So this is 1, 2, 3, 5, and so that's all 1, 2, 3, 5. So this cannot be 1, 2, 3, or 5 because we have 4 of them already. So this is 6. This cannot be 6. This cannot, that forces this to be 1, 2, 1, 2. So this can't be 1, 2. This can't be 1, 2. We know one of these is 3, and the other one has to be 4. So that's 3, 4, 3, 4. This becomes 5, 7, 8, 5, 6, 7, 8, 5, 6, 7, 8, 5, 6, 7, 8. So this is either 4 and 2 and 3, or it's 3 and 1 and 5. So this can't be 5. This is 7, 8, or 9. That can't be 9, obviously. This is 7, 8, or 9. Mm-hmm. This is 1 or 2. This is 1 or 2. So we have 1, 2, 3, 4, 5. So this cannot be 5. This is 6, 7, 8, 9. This is 6, 7, 8, 9. Obviously can't be 9. Okay. So 5's one of those two. This is 1 or 2. So 1, 2, and 3 are accounted for here. So this is 4, 5, 6, 4, 5, 6, 7, 8, 9. Right? So no 6s, no 4s, no 6, 9. So if this is not 2, 3, 4, which this would have to be 1, 3, and 5. So this would have to be 2, 3, 4. And if this is 1, 3, 5, the 4 would have to be here. So this can never be 4. Because either this is not 2, 3, 4, in which case there's no 4 in one of these three spots, or... Oh, that's interesting. I think it's the same one here, right? So if this is... Okay. Let's go back. Let's not clear that. What happens if this is 1, 3, 5? Right? If this is 1, 3, 5, where's the 4? The 4 has to be one of those. So this is 2, 3, 4, right? But that can't be 4 because of these. So we have 2, 3, 2, 3, 4. 1, 2. This would have to be 2. And you would have a 1 somewhere here. So this would be 2, 3, 4, 2, 3, 4. This is 1, 3, 5. So the 5 cannot be there. So you have 1, 2, 2, 3, 2, 1, 2. So that's the case of that's a 4, right? So then we have a set of 1, 2, 3, 1, 2, 3, 1, 2, 3. Now what happens if this is 1, 3, 5? Right? If these three are 1, 3, 5. That means where's the 4? The 4 has to be here. So this would have to be 2, 3, 4. This would be 1 or 2. That would be the 1. So this is 4. So this can't be 4. And this can't be 5. So it's the same situation, right? So basically we know this is 1, 2, 1, 3. This is 1, 2, 3. This is 1, 2, or 3. Right? And then we have 1, 2, 3, 4, 5. 2, 3, 4, 5. So this is 1, 2, 1, 2, 3, 1, 2, 3, right? So this gives us 4, 5, again, So this is, all of these have to be 4, all of these have to be 4, 5, 6, 7, 8, 9. No 6, 9 here, no 4 here, no 6, no 6, no 6. So one of these is 4. Hmm. This can't be 1, 2, or 3. So since that can't be 1, 2, or 3, this cannot be 1 or 2. It still could be 3, though. Okay, so this is 3 or 4. We have 1, 2, 3, 5, 1, 2, 3, 5, 3 and 4. Oh, one thing we know is these 3 cannot be the same set as these 3. And these 3 cannot be the same set as these 3. Right? But we only know... Okay, so this has to be a 3. So 6 is one of these 2. Hmm. Okay, where can the 7, 8, and 9 be? Maybe we have to look at the middle. We know, okay, so there's 2 out of 1, 2, 3 here. There's 2 out of 1, 2, 3 here. Oh, interesting. Okay. If this is 4, 5, I guess there could be 2 out of 1, 2, 3 here. Right. If this is 4, 5, this would have to be 1 out of 1, 2, 3. And you would have 2 then here, which is possible, I guess. This cannot be 1, 2, 3. So this is 4, 5, 6, 7, 8, and 9. This is also 4 through 9. 4 through 9, 4 through 9. All of these are 4 through 9. Obviously no 9. So it could be that's 1, 2, 3, that's 1, 2, or 3, and that's 1, 2, or 3, right? Or it could be that there's 2, 1, 2, or 3's there. Hmm. Um. Okay. Can this be a 4 or 5? If this is 4 or 5, this cannot be 4 or 5, and it can't be 3. So this is 2 that are greater than 4 or 5. This would be 4 or 5. I guess this would have to be 1, 2, 3. That would be 1, 2, or 3. That would be a 1, 2, or 3. So that's possible. This would have to be 3, right? So the 4 or 5 could be there too. Um, This is 5 or this is 5. So 1 goes with 8. The 1, 2, or 3 could be any of those. The 1, 2, or 3 could be those two. 1, 2, 3 could be any of those. And 1, 2, 3 could be any of those. Or 1, 2. 1, 2, 5, 6, 7, 8, 9. Hmm. Hmm. So if this is okay, so this can never be 6, right? So it could be 1, 2, 1, 2, 6, 7, right? Therefore, that would be 3. This would be 4, 5. Huh. 1, 2, 1, 2, 6, 7. So this would be 3. This would be 4, 5. 4, 5, 6, 7, 8. Oh, wait. Hold up. No, okay, never mind. We have 2 out of 1, 2, 3. 2 out of 1, 2, 3. Hmm. There's at there's 2 at most out of 1, 2, 3 there. Hmm. If this is 1, 3, 5, this could be 4, 6. If it's 2, 3, 4, this could be 4, and that would be 5. Okay. Hmm. Hmm. Okay, so there's only 1, 4, 5, and 6 out of these, out of these. So there's only 1, 4, 5, and 6 in these two rows taken. There's one of each, shall we say. So there's only one of each more in there. I don't know if that helps us much, though. We know the 6 is one of those two. Hmm. Okay, what do we think about here? Thinking about eliminating that 7 to 6. But that might be actually possible. So all of these add up to 9. So you have 1 and 8, 2, 7, 3, 6, and 4, 5. Does that help us any? If this is 4, 5, this would have to be 6, 7, 8. 7, 8. Maybe that's one way we go down. So what happens if this is 4, 5? This becomes 6, 7, 8. So this cannot be 6. This cannot be 6. So this has to be 6. So therefore this can't be 6. So this can't be 7. Obviously none of these could be 4, 5. Then that forces this not to be 6, 7, 8. No, 1, 2, 3. This is 1, 2, or 3. This is 1, 2, 1, 2. This becomes 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this can't be 1, 2, or 3. This can't be 1 or 2. So this can't be 6, 7, 8. So we have, this is 6, 7, 8. This is 6, 7, 8. This is 6, 7, 8. We gotta have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, hold up. We have something. Do we? Do we? Do we really? I'm not sure. No, not necessarily, because that's 1, 2. That could be 1, 2, 6. Mm, right. So the only way this is not 7, 8 is if this is 1, 2, 7, 8. And this would have to be 7, 8. So we know it's 1, 2, 7, 8. So this can't be 1, 2, 7, 8. That can't be 1, 2, 7, 8. That can't be 1, 2, 7, 8. So in that situation, that's 1, 2, 1, 2, right? Oh, interesting. Huh. If that's the case, so this, okay. So the only way this is this square cannot be 7, 8 is if this is the case. You have one of the 1, 2, 7, 8s here, one of the 7, 8s here. So this cannot be 7, 8. But what we know then is that this has to be 1 or 2. This is 1 or 2. This would have to be 3. So the 3 had to be here. So this cannot be 6. And then that would force that to be 6. So the only case this is not 7, 8 is it has to be 6. I don't know how much that helps us, but it gives us something at least. Right? Or maybe we just continue down that route, right? So, okay, let's say this is 1, 2, 7, 8. This is 7, 8, 1, 2. This can't be 1, 2, 7, 8. This can't be 1, 2, 7, 8. This can't be 1, 2, 7, 8. So this has to be the 3. This is 1, 2, 1, 2. This has to be 3. which means these three are 1, 2, 6, right? So this can't be 6, that can't be 7. This is 3, this is 3, this is 3. So this is 3, 4, 5, 6. This would be 6, because this cannot be 6. 1, 2, 3, 5. So this would be 6. This is 5, 4, 5, 7, 8. This would be 5, 7, 8. This could not be 4, 5. This could not be 4, 5, 6. This can't be 4, 5, 6. We would know. Okay, so this would have to be 6 then. This would obviously not be 6. So 6 would be one of those two. If that's the case, then this could not be 4 or 5. This could not be 5 because we're missing 1, 2, and 3. We would have 1, 2, 3, 1, 2, 1, 2, 3. So this would not be 1, right? This would have to be either 1, 5 or 2, 3. I mean, it all seems still plausible. Okay, so maybe going down this route is probably not the best way. So one thing we do know now is this is 6, 7, or 8. Okay. Can this ever be 1, 2, 6 is the question, right? So say this is 1, 2, 6. That means 3 is here, so this can't be 3. This can't be 6. No 6, obviously. This would be 1, 2, and 6. This would be 1, 3, 5. Therefore, this can't be 6. This can't be 6, so this would have to be 6. So you'd have 6, and this would be 1, 2. So this would have to be 5 or 7. This can't be 3 or 6. Can't be 6. This can't be 3. This can't be 6. So this is 6. Which means none of these are 6. So that's 6 over here. Therefore, this would have to be 6. Which means this is 7 or 8. The 6 is here. This can't be 6, so this would have to be 3 and 6 here. So no 3, 6, no 3, 6, no 3, 6, no 3, 6. No 6, no 6, no 6. One of these has to be 1 or 2. Well, I guess this could be 7, 8. So no 6 here. This cannot be 7 or 8. This can't be 6, so this has to be 6. Which means this can't be 6, so the 6 would be here. I mean, it still seems reasonable. No 1, 2, no 1, 2, so this would be 3. This would be 6. This couldn't be 3, so this would be 3. So this could not be 3. Which would mean this is 3. So this could not be 3. So one of these is 3. You have a 6 here. You have a 5, 7, 8. This can't be 6, so this would have to be the 6. This cannot be 3. This is a 4, 5, so this can't be 4, 5. So this is one of the 1 or 2s. The 3 would have to be there. I mean, this all seems plausible. This can't be 1 or 2, so this becomes the 1 or 2. This can't be 7 or 8. One of the 4 5s is here. This would have to be 3. I mean, this all seems plausible right now. This is 1 or 2, so this has to be 1, 2, 7, 8. One of these is 1 or 2. We don't know which. One of them obviously is 4, 5. This can't be 5 because you have 1, 2, 3, 4, 1, 2, 3, 4, 5. So this would have to be 7 then. Which means this cannot be 2, 7. This cannot be 2, 7. This can't be 7, so this has to be 7. Which means that has to be 7, so this can't be 7. So this can't be 7. Again, this can't be 7. No 7s here, so this is 4, 5, 8. So the 2's here or here, which means, okay, so the 2's here and here, which means one of these, this is 2, so this cannot be 2. So this becomes 1, 5, and 3. This is 4, so this is 2, 3, which means this is 1, that's 2. This can't be 2 or 4. No 4 or 7. No 4. This can't be 4. I mean, this all seems valid. So this is 3, 4, 5. So this is 5 then. This is 5. This is 1. This is 2. This is 1. This can't be 5. That can't be 5. That can't be 5. This can't be 2, which means that can't be 7. This can't be 4. So this is 2, 7. So no 5, no 7, no 5. Which forces that to be 7. Oops. What the? That's not what I wanted. This is 7 then. One of these two is 7. This can't be 2. I mean, this all seems valid, so... Going down this rabbit hole, I don't know if it makes sense. right? So then you would have 2, this would be 4. This can't be 4, so that can't be 5. Yeah, I don't know if this makes sense to go down this rabbit hole. So this would have to be 1. This is 8, this is 5, this is 4, this is 9, this is 4. Yeah, this all seems valid. This might actually be the winning the not the winning the correct track. Hmm. Yeah, maybe it's showing that it looks like that the if this what happens if it's within the 6, right? Hmm. Maybe that's the route. So what happens if this is not 7 essentially, right? If this is not 7, then what this becomes, this then has all the sets from 1 through 6. So then, okay, so say that's not 7. This has to be 7, 8. This has to be 7, 8, 9. That's 7, 8, 9, right? I mean, that seems like it's okay. What does that mean for these then? Okay, so... Um, I mean, it still seems kind of valid. Let's just, I don't know. I guess we can go down that path then. What happens if, so say this is a 4, and say this is a 3 and a 4, which means this is 1, 5. So this can't be 3, this can't be 4, that can't be 4. There's no 5 possibles here. So this can't be 5. This has to be 3. Oh. Okay. That makes that easy. So that cannot be 3 and 4. I think it also means it can't be 3 and 5, right? Or 4 and 5, right? If this is 4, that's 5, and this is 1, 3. This is 3, but it has to be 3 with 1, 5, which also doesn't work. So, okay, we've eliminated 4. I don't know if that helps any. Actually, it does a little. If this is not 4, this can't be 3. And since this is not 3 anymore, this has to be 2 out of 1, 2, or 3. Aha. So this is 1, 2, or 3, which means this can't be 1, 2, or 3. This can't be 1, 2, or 3. Most importantly, this can't be 1, 2, or 3. Well, okay, I don't know if that's most important. This is 4, 5, 6, 7, 8. This can't be 1, 2, or 3. 6, 7, or 8, right? Um... Interesting. What happens if it's 5? Huh. So that was if it's 4. So that eliminates the 4s then, because this would have to be 3, 1, 5. Um, hmm. Okay. So what happens if this is 5? If this is 5, okay, let's say it's 5 and 4. Then this becomes 2, 3. This would have to be 1. So this would be 5 and 3, 2, 1. This would be 3, 2 and 4. So this could not be 4 or 5. This can't be 4 or 5. This can't be 4 or 5. This can't be 4 or 5. Oh, hold up. We forgot to do that. Okay. So this cannot be 6, 7, or 8. Okay, so let's go back to this. Okay, so if this is 5 and that's 4, this becomes 2 and 3. This can no longer have a 4. This can't be 5 specifically. This can't be 5. This can't be 4. Oh. So this would have to be 3, 5, and 1. So that'd be 2, 3. And you'd have 6, 6, 1, which is not possible. So it cannot be 5 and 4. This seems so inelegant, though. But so say this is 5 and 6. So this would be 1, 2, 3, right? So there's no 6s possible. So this can't be 6. This could be 5. This could be 5, but it would be 1, 5, 3. No 5 or 6, no 5 or 6, no 5 or 6, so no 4, 5, no 3, 6, no 3, 4, 5, 6. No 5, so that can't be 4, no 6, no 5, no 5 or 6. One of these is 7 or 8, so that forces this to be 7 or 8. So that can't be 7 or 8, no 6, no 6, no 5. One of these is 5. So if this is 5, one of these is 5. So this can't be 5, that can't be 5, that can't be 5, that can't be 5. Right? Because one of these is 5, one of these is 4. Oh. You have a 1, 2, 3, 4. I think that's the key, right? So if you have, yeah. Say this is any number that's 6 or below, right? If this is any number, okay, well, we just shown that 5 does not work. So we showed that 6 doesn't work for it. So if this is 5 and that's 6, this is 1, 2, right? Oh, I think that's what it is. 1 of 4 through 6 is here. 1 of 4 through 6 is here. 1 of 4 through 6 is here, right? But one of these has to have, we know, okay, so say this was a 4 or whatever. It cannot be 1, 2, or 3. Say this was a 4, right? If this is 4, this has to be 3 or 5. Okay, well, 4, then this is 3, 1, 5. And this would have to be 5, and that's 1, 3. So that just can't be 4. But even say this is 5 or 6, right? If this is 5 or 6, one of these has to be 5, and one of them has to be 4. Or one of them has to be 6. But yeah, I'm trying to think of the logic. If this is 5 or 6, one of them has to be 4, obviously. So then this would have to be 7, 8, 7, 8, 9, 7, 8, 9, right? One of them would have to be 4, and then the other one would be the 5 or the 6, right? Oh, that's what it is. So say this is 4, 5, or 6, right? One of them would have to be the other one, 4, 5, or 6. But the problem is you can only have one 4, 5, or 6 amongst these three, right? Amongst these sets of threes. All three of these sets of threes, right? Because they all add up to 9. So if you have a 1 from 4, 5, or 6 here, that forces the other ones to be here, right? So that well, first of all, then you can't have, I guess you could have No, you can't, right? The only one that was possible was this was 4 and that's 3, right? And then you could have a 5. But the problem is that this would become a 3 and this would have to be 1 5. So you're forced to have that as a problem, right? Or that becomes an issue. So that is contradicted. So that would only be for 4. If you have 5 and 6, since you now know that this has to be 1, 2, or 3, the 4 and the 5, so say you have the 5 and 6. The 4, 5, or the other two 4, 5s, and 6s have to be here and have to be here. But that means that this can't be 4, 5, 6. This can't be 4, 5, or 6. So therefore, you know, and they all, since you have to have a three different situations that add up, or sets that add up to 9, this can no longer be 5 or 6, right? So if you had 4, 5, and 6, that forces this to not be 4, 5, or 6. And the problem is that if you have a 4, this becomes a 3. So this becomes 1, 3, 5. And the 4 can only be, next to a 3 or a 5, which means it also has to be 1, 3, or 5 because it cannot be 2, 3, 4 anymore, right? So if this was a 4, this forces this to be 1, 3, 5 and this to be 1, 3, 5, which is a contradiction. Now, if this is 5 or 6, where can the 4 or the 5, where can the 4 or the other 5 or 6 be? It has to be in one of these two spaces, which forces that to be a 2, 3, 4, or a 1, 3, 5, or 1, 2, 6. But the problem is that this cannot be the equivalent, right? Where is the 1, 3, 5 if this is 5? This can't be 1, 3, 5 because it's either 1, 2, 6 or 1, 3, 4. Well, actually, this one has to be 2, 3, 4. And this would be 1, 2, 6. But the problem is there's no 1, 3, 5 possible because that's 5, right? Same thing with this. If this is 6, say this is 6, right? This would have to be 1, 3, 5. But then you have a 4 and a 5 somewhere here and here. So one of these would have to be 1, 3, 5, and you have a contradiction. Therefore, the only one that works is 7 and a 6. Right? Okay, that was pretty cool. Actually, I like that a lot. Not easy to see, though, but... So, like, I just had to go through the scenarios to actually understand what was going on. So now we know this is 6, so this cannot be 6. So we have a 1... This is 3, so this cannot be 3. This cannot be 2, 3, 6, 7. No 2, 3, 6, 7. No 6, 7. So this is 8, 9. So this is 7. So this forces this to be 6. So this can't be 7 or 6. No 6. So the 6 is one of those two. This can't be 6 or 7. This can't be 6. So this is 6. So this can't be 6. This can't be 6. That can't be 6. Therefore, this is the 6. Okay, and that's why it was working for when we went down that route. This has to be 7, 8. This can't be 7 or 8. It's because, yeah, it would speak. So this has to be a 3. This has to be 1, 2, and 6 because there's no other possibility here. So this can't be 6. This can't be 6. This can't be 6. None of these can be 6. This can't be 6 because of that. This can't be 6 because this is 1, 2, 6. This can't be 6 because the 6 can't be here. This can't be 6 because of this 6. That can't be 6 because of that. So this has to be 3 and 6. So we know this is 3 and 6. So no 6, no 3, no 3, 6, no 3, 6. This can't be 3. This has to be 1 or 2, so this can't be 1 or 2. This is 3, 4, and 5. This has to be the 6. And yeah, everything now follows from that. So that was actually very interesting logic that basically forced this to be a 7. So this is 6. Where are the 6s? This can't be 6. This can't be 6. This can't be 6. So this has to be the 6. So this cannot be 6. So this can't be 3 anymore, so this has to be 3. This can't be 3, so one of these is 3. This is 7, 8, this is 7, 8. We have one of the ones, one or twos here, and then this would have to be 4, 5. So we have 7, 8, 7, 8, 9. So the 7's here. This is 4, 5, 7, 8. So we have 4, 5, 7, 8, 7, 8. So this has to be 2. And this has to be 1. Which forces this to be 1, and that's 2. And this is 1. So that's 2. This is 3, 4. So this is 5, 1, 1, 2. This becomes 1, 3, and 5. This becomes, so this is 3, 4. No 4 here. So this can't be 5, no 5, no 5, no 5, no 1. This is the only place for 2, so this is 2. So this cannot be 1 or 2. This can't be 5, 7, or 8 now, so this is 4. This is 5, this is 8, so this has to be 2, 7. This can't be 7, so this is 9. We have 9, 4, this becomes a 3. This is 8, this is 7. This is 8. No 7 in each of these spots. No 8s here. This can't be 8. This can't be 9. So we have 7, 8, 7, 8. So this is 5. So this is 5. This is 3. This has to be 1 and 5. So this is 2 and 3, 4, 7, 8, 9, 2 or 3. This is 5. This is 4. This is 9. So this can't be 5, this can't be 4, no 4, 5 or 8, no 5 or 8, no 7, 8, and 9, no 7, 8, and 9. So this is 4, 5, or 6, no 6, no 5, 8, no 4, 8. This is forced to be 7. This can't be 1, so this is 6, 2, 1, 2, 7. This makes that 8, 7. This is 3, this is 5, 1. 2, 1, 2, 3, 9, 4, 5, 4, 6, 9, 7, 8, 5, 4. This is 3, 4, 7, 8, 9, 8, 5, 8, and 7. And that's a solve. Wow, that was really clever. I really like the use of that 7, that forcing that situation, right? Because it could not be the 4 forcing this to be a 3, which forces that to be 1, 3, 5. And that having to be 1, 3, 5 also was kind of clever. And then this 5 or 6 forcing these to be specifically 4 and 5, which meant that there was no 1, 2, 6 in any of these 3 pairs. That was very clever. I'm not sure if I could have seen that without going through an example, but sometimes you need to do that. Anyways, I hope you enjoyed, and I'll see you next time. Take care.